All right, today just did homework questions, elimination method, section 8.2. This is my favorite method. Well, actually, it's my second favorite method. Elimination. It's where you stack them up and then you knock out the variables and have some fun that way. Okay? It takes a little bit of time, but we're going to do something else also with it today. So, here's a list of things to check off your list as we go through. Give a system a question. This is just textbook language. Two equations interchanged. That means a substitution. An equation multiplied divided by a non-zero constant. That's for the elimination method. Also, a constant multiple equation add to another one. That's elimination. Substitution we did for today. It's where you set something into something else and solve it. So today we're going to concentrate on those. The directions on your last exam will say use the elimination method. Or it'll say use the substitution method. And they don't say either one. We'll talk about how to do that on Monday. All right? So, couple of lines, definitions, terms. Just remember, review some of that. A consistent system is one that has one solution and the lines aren't parallel. Do you know what linear equations are, by the way? Yeah, y equals like mx plus b. It's to the first degree is what I'm trying to get after. So if you have two lines, you have three possibilities. They're either going to be parallel, they're going to intersect, or they're going to be the same line. That's the only three possibilities. So a consistent system is one known as an intersection. You have to write the words consistent in your homework and inconsistent. So one solution, consistent. That's not that difficult. Just make a little note next to the picture. Identical lines are known as dependent and consistent. They have an infinite number of solutions. This is just for your word problems. It's for your wording on questions where it says identify if it's consistent or inconsistent. And then it'll say if it's consistent, is it dependent or independent? So, identical lines. Obviously, one has the same equation as the other one. Yes, it happens. It happened in your homework, actually. You got one where it didn't work. Like 3x plus 2y equals negative 1. Another one would be 6x plus 4y equals negative 2. Multiplying everything by 2. That's an example of an infinite number of solutions. Everything that works in one will work in the other one, so it's known as the dependent and consistent. 2, 4, 6, nice. All right. I'll just count up the number of kids. Parallel. This gets an inconsistent with no solution, are the key words on this one. The key words on this one are mainly for multiple choice exam questions with the choices not given to you in terms of numbers, but in terms of words. So you have three choices for each. You have choice A, B, and C, and they have these words. You have to remember what the words mean to answer the question. So, parallel lines have no solution, known as an inconsistent. Okay? So if it has a solution, it's known as consistent. If it has a solution, it's known as consistent. If it has only one solution, it's just consistent. More than one, dependent. No solutions, inconsistent. Okay? That's how it works. Solutions are consistent. More than one's dependent. None are inconsistent, i.e. no solution. That means they are parallel. Perfect. I love the elimination method. Love it so much, I'm going to have it this summer. All right, so obviously on these, you want to knock out the coefficients in front of some of the terms. Sometimes you have to multiply both. Sometimes you have to multiply just one. but you're always looking for the x, or you're looking to knock out a y. In this case, I see a very logical candidate. Ding, 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 ding. I'm going to knock out the y. I'm going to use that one. Okay? I see that one because I know I can multiply by a -5. I just started doing this. I always add. I never subtract equations when I do elimination. I always add. You don't have to, but I got tired of dropping negatives, so I always add. That's why I'm multiplying by -5. Okay? I tell you things like that all year. Things that I always do because of practice and because of experience. You don't have to, but you don't have any problems with negatives that way. 5y equals 13. So if I distribute my -5 through, I get -15x minus 5y equals 20. Yep, so then I just add. I don't even have to write it in my work. I know I'm going to add. If you don't write something, you know you're going to add the systems. So it's going to be -11x and 33. X equals 3. Remember, you have to write your equations as an ordered pair. Yeah, I'm getting my eraser. And I'm going to change that right now. -3. And -3. And how do you find it? You always go back to the original. So, the original one, I don't know, either one you want. 3 times -3 plus y equals -4. So, -9 plus y equals -4. Y equals 5. Yes, people lost points on their final because they didn't write it as an ordered pair. You lose 1 point for not following directions. You lose half a point if you drop any units of measure. Okay? That's the elimination method. Nice, neat, and fun. Really a breath of fresh air without using the calculator. Here we go. Let's just do some more examples today. It's Friday. What else would you rather do than the elimination method of solving linear systems of equations? I am too. All right. Who wants to get fancy and go after V, or who wants to be boring and go after U? Boring? All right.
Fancy.
All right. We'll go after the U's. I'm sure you're going to multiply by -3. -3. -3. -9u plus 15v equals -51. Now remember, I always add. Rarely do I subtract. That's just, you drop negatives. Yeah, so this is nifty. Remember, it goes in alphabetical order. So it would go U first, V second. Alphabetical order. That's how you list your answers in ordered pair. So U is first, V is second. You write the wrong way, that shows you don't know the alphabet. All right. It happens, trust me. Excuse me. 9u plus 2 times -3 equals 0. Pretty nifty. I like the fact you don't even have to use a calculator. U equals 6/9 divided by 3, 2/3. So that would be an inconsistent or a consistent system? Which words do we use?
Consistent.
It would be consistent. Okay? A consistent system. All right. Nice little description. Nice little word. Yes. All right. You want to try this one on your own, or you just want to do it together? Huh? 2/3. Right. Okay, 2/3 -3. Now remember, it goes in alphabetical order for your solution. So you're going to write your solution as P, Q. letters in the back of the alphabet are for variables. Letters at the front of the alphabet are for constants. So it's no coincidence you're on the back half of the alphabet. I don't know.
Yeah, no solution.
All right. Multiply by 4, 4, 12p minus 4q equals 28. Negative 12p plus 4q equals 3. I don't know why that line's there. I was going to do something different. That's okay. Sure. All right. That knocks out. That knocks out. Nice. 0 equals 31. That is a false statement. 0 doesn't equal 31. That means it is inconsistent. So what's it tell you about the lines? Yeah, they're parallel lines. Okay? All right. Nicely done. And obviously, if they equal each other, that'd be a consistent solution or consistent system because it does have a solution, but they'd be identical lines and they'd be dependent. Okay? All right. Try this one. Again, elimination method. X, Y. I think everybody knows how this alphabet works. Alphabetical order. X and Y. Give this one a go. I'm going to walk around and check your progress. If you're in 7th hour, I'm going to float around and check your progress.
Okay.
All right. So I'm assuming you multiplied by 3. Negative 3, correct. And you got negative 3x plus 15y equals negative 6. 3x minus 15y equals 6. Knocks out, knocks out. Oh, 0 equals 0. Nice. So as a dependent, consistent system, and you have one identical line. All right? Nicely done. Let's get back to some fun ones. Questions on that? I'm trying to cruise along. All right. Oh, this is easy. Solve the system. Oh, elimination method, not substitution. Elimination method. Actually, it's how I solved, isn't it? Yeah. Just put 5 in. X. So relaxing doing systems of equations.
Yeah, after we did all that absolute thing.
Wait a minute, that's not negative 46. Yeah, negative 26. Nice. Okay. So we'll intersect at the point negative 2, 5. Is that what anybody else got? No? What did I do wrong?
Yeah, it'd be negative 26 thirds.
Oh, well, I just thought it was 13. Well, I did. Negative 26 thirds.
Not quite.
There you go, negative 26 thirds. Nice. All right, let's get a tough one. Oh, here we go. I love these problems. This really jazzes it up. Airline that flies from LA to Albuquerque. Oh my gosh. From LA to Albuquerque with a stopover in Phoenix. Okay. What's a stopover mean?
You stop and then you go.
Well, does anybody get off the plane at a stopover?
Yeah, you get off and you go through security again.
And do people always get back on the same flight?
Nope.
No. So you got some people coming on, some people going off. All right. LA to Albuquerque, stopover Phoenix, $90. Let's see. Let's read the question first. How many passengers got off the plane in Phoenix? All right. That's pretty easy. How many passengers did we lose? Fare from, okay, charges a fare of 90 to Phoenix, $90. And a fare of 120 from LA to Albuquerque. All right. We can do this. LA to Phoenix, 90. LA to Phoenix to Albuquerque,
90 minus.
120.
That's just a single flight in between.
I don't think so. Yeah, a total of 185 passengers boarded the plane in LA. Fares totaled 21,000. How many passengers got off the plane in Phoenix? This is where a system is a lot better than you trying to use your algebra to set up one equation with one variable. This shouldn't be that difficult, should it? What do you want to let, I don't know, you want to let x equal the people from LA to Phoenix?
Sure.
And let y equal from LA to Albuquerque? All right. So we got 185 of those people. X plus y equals 185.
Oh, yeah, I remember this now.
Remember what? You've done this problem?
No.
Oh. Nice. $90 to Phoenix. So which one gets the 90 in front of it, the X or the Y? X. So we always take the price times the number of people. And 120 is for the Y. Equals fares total 21,000. Yeah. 21,000.
I just have to figure out how much the gas is worth before the profit is.
Yeah, exactly. That's actually called marginal profit, marginal cost, marginal revenue. They do that in business calc. There's quite a few students actually taking business calc. I tell them to take it this summer and get it out of the way, but some of them will. I think I'll go after the X's first. Multiply by negative 90. That sound like a good plan?
Actually, substitution sounds good.
No, elimination. Negative 90x minus 90y. What's 185 times 90?
What's that?
16,650. Nice. 90x plus 120y. 21,000. Remember, I always add. I just want to know how many passengers got off in Phoenix. So that is our x. That's why I chose the negative 90. Okay? How many passengers got off in Phoenix? So, I should have chose, I did it backwards. That's okay. 30y equals 4350?
Y equals 145.
145? So that means that 40 people got off in Phoenix. 40 people equals X. Nice little problem. I like these word problems. These are pretty nifty.
Too bad.
Hopefully there's one more. I don't know if there is or not. Questions on that? Nice and easy. Oh, the rowboat question. You gotta love it. How many are after this? Oh my gosh. Nice. All right, you want to do the rowboat or the pounds question? All right. We'll give it a shot. How much time we got left? Oh, we got enough. All right. Good. A man rows a boat 500 feet upstream against the current in 10 minutes, and then rows 300 feet downstream with the same current in 5 minutes. Find the speed of the current. That's one of our variables, equivalent to the rate he can row in water. How do you set up the rowboat problems?
Does that make any sense?
Sure.
He goes faster upstream if he does? Oh, no. I'm wrong. I didn't see the time. I just 500 feet upstream, same time.
So how do you do that?
Guy was rowing his arms off.
Well, you want to do upstream?
Upstream, yes.
Okay, so he rows at the same rate, doesn't he?
Yeah.
Okay.
So X plus Y.
So his rate, the man's rate, times 10 minutes. Are we going to do this in minutes, or are we going to do it in hours? Minutes? Okay.
What would we do now?
So it'd be times 10 if we're doing this as far as upstream. One equation for upstream. So R times 10, rate times time equals distance. And I'm just going to make it fancy. I'm going to make it 10R right off the bat. There we go. Plus, against the current. So how does that work? So it'll be minus. Well, the current's fighting against you, so you're subtracting and going slower. So it'd be 10. What should I put down for the river's current? C? All right. That's the river's current.
It's like our X and Y.
Yeah, it's like X and Y. You want to use X and Y? We can.
You want to make it boring?
I was just trying to jazz it up. 10x minus 10y. So x is the man's rate. Y is the current's rate.
It's equal to
And these are both rate times time. Time times rate. And those equal distance, so it equals 500 feet. Downstream. Says he then rows 300 feet downstream with the same current in 5 minutes. So 5 times x plus 5 times y
oh, it's going to be
equals 300.
or no. This is
We're trying to find the speed of the current, so let's multiply the bottom one by -2. You want to? So we'll knock out the x's. -2, -2. So I have 10x minus 10y equals 500, and -10x, -10y equals -600. It works so well when you do this.
why did you multiply by negative?
I'm knocking out the x's.
Oh, because you want to get rid of the X's.
Yeah, I'm looking for the current rate. So I got -20y equals -100. 5 feet per minute. Is that fast? Eh, not really. Okay. That would be 1 inch per second. Nice. All right. We'll do the cashew mixture problem and probably call it. I love these questions. The other questions I like more are this one, but we can't do them all. Oh! All right, we'll go back. You guys want to get this one to go on your own?
Sure.
Merchant wishes mixed peanuts costing $3 per pound, and cashews costing $8. Oh, I'll give you one hint on this. You set up one equation for pounds and one for cost. Okay? One for pounds, one for cost. The pounds is easy. What's the pounds going to be?
X plus Y is equal to 180.
Yeah, x plus y equals 60, isn't it? Peanuts, cashews, 60 pounds. X is pounds of peanuts. And y is pounds of cashews. Pounds of peanuts, pounds of cashews. Now the cost. $3 a pound for cashews. So that's 3y. Peanuts costing 3 pounds, thanks.
3x plus 8y equals 3.
So it'd be 3x, $3 per pound, and $8 a pound of cashews, and $5 a pound for this. So 5 times 60. Okay?
Which is 300.
It is. How many pounds of each should be mixed? So it doesn't matter what we choose. I choose -3 first. How about that?
Negative.
That way we can knock out the x. So I have -3x minus 3y equals -180. 3x plus 8y equals 300. Anybody get 24?
Yeah.
Nice.
X times 6.
And go back to the original. 60 minus 24. 36. So 24 pounds of cashews. It is. And 36 pounds of peanuts. Word problems in parentheses. No, not like word pairs. Okay? So, cashews and peanuts. I think that's probably it. I'll do that one some other time when we're together. Initial velocity. On these, you just put in the numbers and solve for V and S. This is time. That's time. And this is S of T. Kind of like Y's. And you just figure it out from there. Okay? What page is this on? Is it? I can't get there. All right. So yeah, page 612. And, oh, there we go. The acceleration problem I want to hit. So we'll do page. Oh, see, I can't write on that page. Because it doesn't let me write on some of those systems like that. There we go. So, page 612, 1 through 33, every other odd. All right? And work on that now. If they don't feel like working, like 7th hour wouldn't. But anyway, you can just double it, make them odds, quadruple it, you can make it all. So have some fun, get some work done, and enjoy the rest of the week. And I got to go. See ya.